from the minute you decide you want to build a battery system, or the minute you decide you want to deploy an energy storage project or own an energy storage project, we provide every service that somebody could need with respect to the safety side of operating that battery system or building that battery system.
The Solar Podcast is brought to you by Continental Energy Solutions. I'm Tim Montague, your host. Today on the Solar Podcast, we're taking a deep dive into energy storage and energy storage safety. My guest is Nick Warner. He is the co-founder and principal at ESRG, or Energy Storage Response Group. Welcome to the show, Nick.
Thanks, Tim. It's a pleasure to be here.
So, storage is in the news now on a daily and weekly basis, good, bad, and ugly, right? It is the bee's knees when it comes to a high penetration renewables grid. When we get high percentages of wind and solar on the grid, storage becomes an essential component. And of course, storage provides many grid services that are driving ROI for commercial industrial customers and grid operators. Something like 10 terawatt hours of storage are necessary on the grid for the long haul here by 2035. And so we're going to see more and more projects like the Moss Landing project, which is a 750 megawatt hour project of Tesla's and PG&E's, where they're replacing a fossil plant with storage. So give us a little bit of background on yourself. How did you get interested in storage?
Yeah, sure. So I'll be honest, I kind of stumbled into storage. I won't say necessarily by mistake, but had a wild hair, as many young men at the tail end of their college career did. Some things kind of fell through on that pathway, and I ended up taking a last minute internship as a research assistant at the battery lab at the Center for Automotive Research at Ohio State University. So I've been working on a renewable energy project. My advisor at the time, Jan Guznik, along with Giorgio Rizzoni, had kind of seen the writing on the wall for fuel cells for electric vehicles back in the late aughts, and decided to convert the fuel cell testing lab at the Center for Automotive Research into an energy storage lab. So I started there shortly after they had made the switch. And they were actually doing a lot of private research and really a lot of consulting stuff versus some of the academic stuff that you kind of would have expected for a university. Started working there, spent the first year there as an undergrad, decided to stay in and do my master's work in the same lab. Spent the first year trying desperately not to get myself typecast into batteries. And then somewhere between the first and second year, saw that the future was energy storage. And really decided to embrace it. Finished my master's in battery second use, which is really what got me interested in grid stuff and ultimately got me into safety that I'm doing now. But decided to stay there for a couple more years and continue to run the lab. Supported a lot of the student motorsports projects that were going on there. In fact, saw that just a couple of days ago, a battery pack that they had built broke a world record for electric motorcycles again. So, shout out to my alma mater, and proud to see that they're still doing awesome things over there.
It's heady days in both mobile and stationary storage. Of course, most consumers are going to touch batteries or big batteries through their electric vehicle or a consumer application like a power wall. And Tesla is, of course, the thought leader in this. But behind the scenes, many C&I customers are now installing storage for things like frequency regulation, resiliency, ride through, and other grid services. And then in markets like California, of course, where you have the duck curve because of the high penetration of solar, where solar is really beating back grid demand during the middle of the day, but then people come home at 5 o'clock, the solar is turning off, and we need more energy on the grid, and storage is a nice complement to that. Give us some context with ESRG. How did you guys come together, and what is the market that you're going after?
Yeah, sure. So, a little bit about ESRG. We kind of see ourselves sitting at the nexus of product development, of project development, of engineering, and of public safety. And that is with regard to all things energy storage safety. So, the way we kind of describe that is from the minute you decide you want to build a battery system, or the minute you decide you want to deploy an energy storage project or own an energy storage project, until 20 plus years later, when you're packing that thing up on the truck to haul it off at the end of its life, hopefully after a long, normal, healthy, productive life, we can be there to hold your hand for all things energy storage safety. So whether that is literally helping somebody design a safer battery, whether it be for an electric vehicle, for a grid application, helping them assess the safety of a battery they're evaluating, helping them get that system permitted, performing the hazard mitigation assessments, the safety review, whether that's training the fire department and putting together the emergency response plan for if something goes wrong, or whether that's continuing to be there and available as a subject matter expert for the system throughout its life or at disposal. We provide every service that somebody could need with respect to the safety side of operating that battery system or building that battery system. So how we kind of came together, I had previously been at DNV GL, was heavily involved and developed a lot of the safety and testing stuff they were doing there. One of the guys I had been working with in the testing that we were doing in Central Ohio was a fire investigator, was heavily involved in the public safety sector here. He had some ideas about things that the energy storage industry wasn't really doing well, that they were going to have to get better at, given the aggressive deployment schedule they were anticipating. He was seeing a lot of the products we were testing, a lot of the safety issues that they were having. He had some ideas about, what the industry needed to do better. And that was Tom Bensen, who's one of my co-founders. Likewise, Paul Rogers, our other co-founder, formerly with FDNY, as their ESS subject matter expert, was heavily involved in permitting and rules development and code making for energy storage. He saw what the pain points were for people trying to get into the city with energy storage, had some ideas about what people needed to do with respect to response planning, disposal planning, decommissioning, and how better to handle that. And then I myself, had some of my own ideas about what folks could do better, and was kind of the glue that brought it together. So, we kind of started talking, and ultimately, ESRG was born early last year, but took us a while to get up and running. We all kind of had our own projects going on as well. And we've been fully operational now for just under a year and a half.
Excellent. So on a 1 to 10, how mature is the stationary storage industry in general?
Ooh, 7 is the safe answer in a lot of 1 to 10 scales. I think in some cases, I would say 6 or 7 may cover some folks, and other places we may be closer to an 8 or 9. I think that the two things that are still lacking, though they've, I think, broken speed records and have come a long way, is codes and standards. A couple of years ago, I think back to 2017, there was no 9540A. It's in its 4th revision now. UL has come a really long way with that. They're starting to put together a standard that's going to be workable for everybody. There's still some pain points with it. We're still kind of learning some of those as we go. But as 9540A continues to evolve, and as the industry continues to understand what that means and how to implement it, that will be one of those final things that gets us another half of the point there. I think the fire codes as well are one of those things that need just a little bit more maturation. We're working really hard on Nfpa 855 right now, getting into some really long meetings, trying to get the next revision of it finished up, and it's got a little bit of a ways to go. But hopefully in the next 2 years we'll have draft language there that will be great. And then I would say kind of the last point there is, to get us from a 9 to a 10 is just the industry themselves kind of starting to understand this stuff a little bit better. But in terms of the technology, and are there manufacturers who truly understand safety, truly understand codes and standards that are at the cutting edge of that are at that 10 right now? There absolutely are. They're very much the early adopters, if you will, though, and a lot of the industry is still catching up. So there's light at the end of the tunnel. We're close, but we're not quite there yet.
So you've touched on a few things that we should probably flesh out a little bit. UL 9548, that is a standard applying to thermal runaway. And I want to tie this into what's going on in New York City, because New York is one of the best markets for storage with their VETR program. But New York City has a unique take on storage, and maybe that was founded in reality. And I'm curious what your team makes of that whole situation. But first, let's talk about UL 9548. What is it, and um, how do manufacturers get through that process? How long does it take?
Mhm. It really depends. Some of the labs that are performing that testing are really backed up. It can be several months to get in. In other cases, we ourselves, we do battery fire testing. We do 9540A. All we do is battery testing, so we don't tend to have the lead times. There can be some administrative hoops to jump through sometimes, depending on what partnerships you already have in place for your nationally recognized test lab. But ideally, assuming everything went great, we could move somebody through it in as short as 3 or 4 months. Where the challenges are really coming and stacking up are the performance of systems during the testing, whether it's at the cell level, usually at the module level or at the unit level. The manufacturer, if they haven't done any testing themselves, are not getting the performance out of the battery that they want. That's going to result in them needing to redesign the system, or else they need to install a lot of active fire protection measures that are going to make installation in a lot of applications really difficult. So if folks, you know, put the due diligence in ahead of time, put the work in ahead of time to really build a safe battery, if they truly understand it, they can breeze through the process pretty easily. And we've definitely had manufacturers that have done that. Uh, but more often than not, when folks approach us for it, we look at their system. We recommend they do what we call kind of pre-certification testing. We run the battery through essentially the same thing it's going to go through in the tests, but without the onerous data acquisition requirements, without all the box checking that comes with actual certification. It's a fraction of the cost to run the test that way. But if their jaw is going to hit the floor when their battery catches on fire, we can get it out of the way in a lot more cost-effective manner. Then go back to the drawing board and start helping them work through some of the issues with the system before they waste a lot of time and money in the certification process. And quite frankly, that's where a lot of our customers are landing. So, the short answer is, if everything is perfect, which it rarely is, a few months. The reality of that is it's been, in a lot of cases, 6, 9, 12 months or longer, depending on how the redesign process for a system goes, if it needs to be done.
Nobody likes it when their battery catches on fire, and the manufacturers are inspired to pack as much punch, allow for as much fast charging and discharging as possible. And the downside of that is that it can potentially lead to thermal runaway. In
Right.
general, my sense is that batteries are actually very safe. You hear about some sensationalized events,
Mhm.
and things do happen, of course. But given the volume of storage that we have in the marketplace compared to the hazards that are occurring both in mobile storage and stationary storage, it seems to me like we're on a good trajectory. And but let's walk through kind of some of these use cases. First of all, for manufacturers, tell us about how you help manufacturers build and bring to market safer products.
Yeah, sure. So, at this point, we've done a lot of testing. Going back to 2016, the group that we do our large scale fire testing with, by quick back of the envelope count, we're somewhere in excess of 150 medium and large scale fire tests. And by medium, I mean at least a pack of a couple of kilowatt hour capacity, up to multi 100 kilowatt hour systems. We've done uh, close to 20 full scale unit or rack tests at this point of systems, and a whole lot of modules. We have folks on our team who have experience with fire dynamics, folks on our team with experience with electrical engineering, and a lot of times we can look at a system and tell you what's going to be problematic with it. If you, like you mentioned, the emphasis in the industry, or the goal in the industry is to pack as much punch into a module as you can. And the methods for doing that don't typically involve spacing between batteries or insulation or air gapping or anything like that that might kind of help mitigate cell-to-cell failures or cell-to-cell propagation during a failure. So, we try to work with our clients to understand right out of the gate what their performance goals and requirements are for the system. We look at the system and see if there's any low-hanging fruit that we can identify right out of the gate. And if there is, certainly we attack it. A lot of times, the manufacturers, they're proud of their product, rightfully so. But they seeing is believing. So, we just take the thing out in the field, we set a cell on fire and let Mother Nature do the rest. And then they come back and say, okay, yeah, we got to fix this. So we look at what happened during the test. We will having failure investigators on the team as well. We do full forensic breakdown of the system. We understand what the weaknesses were in the system, what things may have failed. In a lot of cases, we find some really surprising stuff. There's always the usual suspects, but sometimes there's some really funny things that happen in systems too. And we start making recommendations for what can be improved to fix these systems. Almost always there's requirements for manufacturability. We can't really change the design of the product too much because they're almost always relatively committed into the design and manufacturing process. So there's not a ton we can do to improve safety. We do what we can with the product, but then we also talk with them about what they can do at the actual installation level if it's a stationary system to improve safety. The good news is because we have expertise in all aspects of the life cycle of a battery, we fix what we can at the module, we fix what we can at the rack. But if we need to fix some things at the actual full installation level or at the training level, even with systems that are already deployed, we can almost always reach the necessary level of safety. And we've got a lot of tools in our toolbox to help our clients do that.
Tell us a little bit about NFPA and how that relates to all of this. There's the NFPA 855 standard. And there's two things here. There's life safety, and then there's I guess overall battery safety. But how does this come into the mix?
Yeah, sure. So NFPA 855, for the viewers who maybe aren't familiar with this, NFPA is the National Fire Protection Association. They develop what are called model codes and standards, which in a lot of cases are adopted by states or by local authorities having jurisdiction into their own fire codes. In some cases, if the NFPA code itself isn't adopted, it's treated as a standard of care for the industry. It's held as a standard of care if, God forbid, anything ever goes to litigation. Maybe it wasn't the law of the land where you were, but this is considered industry best practice. Why weren't you following it? So NFPA 855 came together in 2017. It is the National Fire Protection Association's effort at putting together a standard for the installation of large-scale stationary energy storage systems. We made it through about the first 2.5 years of the code cycle development pretty well. Had a great group of folks doing the best they could to put the standard together. As the standard started to grow in scope, as it started to bring in a lot of people, it maybe wasn't necessarily intended to at first, or people found out that they were going to be covered under it. We started getting a lot more folks in there. It's become, I won't say more divisive now, but definitely a lot more cooks in the kitchen with respect to the standard. It has grown in scope as well, or rather the scope remains undefined. There's some political wrangling going in there right now, to be entirely honest with you, as to who is going to be covered by it. But yeah, the long and short of it is this is how you should put an energy storage system in the ground if it's going to be grid tied in some manner. Here's what you need to do for a given technology. Here's what safety systems you need to have. In a lot of cases, there's what are called performance-based requirements. It's not install X sprinkler, it's install a sprinkler such that you meet X criteria. And sometimes there's criteria set up in the product standards. In a lot of cases, that criteria is actually decided by a fire protection engineer. So a lot of different considerations in there for an industry that's been essentially completely unregulated until about 2 years ago. there's been some pain and suffering for some folks. Most of the systems that are actually installed now, especially if they were installed more than a year ago, probably are not compliant with this standard. So for a long time, there's going to be a lot of consideration for firefighters and fire departments and how to handle retroactive systems which aren't compliant. But I think the good news is we've got a good groundwork that we're continuing to improve for systems that will be installed in the future. Like I said, there are a lot more cooks in the kitchen, but while it's made the code development process a little more difficult, the good news is more and more folks in the industry are learning about it. More fire protection engineers, more HJs, more manufacturers. So hopefully it continues to improve, but that is the de facto law of the land. But in California and New York, they've actually adopted the International Fire Code, or language from the International Fire Code, which is essentially pulled from Nfpa as their laws.
So you have UL on one side and then NFPA on the other side. NFPA is more code related, and the AHJs are going to be very interested in this. Um, let's talk more about New York, though.
Sure.
New York City is a little bit of a standout. There's some unique codes in New York City related to storage. Is that right?
Yeah, there are. New York City. So New York State has what's called New York State 608, which is their new fire code for energy storage. New York State, along with California, are the first two states in the country to adopt energy storage laws into their state fire code. And the New York State code is actually based on draft language for the 2021 version of the IFC, which is essentially NFPA 855. So they have that, but the city, as you can imagine, being the densest urban metropolis in the U.S., there are simply more considerations for safety for energy storage. You made a great point earlier that batteries absolutely are getting a lot safer. If you look back, even 20 years ago with energy storage, 10 years ago, even with lithium-ion batteries, there were quality control issues. We learned a few years ago that we're not completely immune to those, but we've learned a lot. And in general, the batteries are getting better. The failure rates on the batteries are getting better. Unfortunately, if we decrease the failure rate of the batteries by an order of magnitude, but we increase by 1 or 2 orders of magnitude how many batteries we build, failures are going to continue to remain a fact of life. And even though the systems in general are getting safer, the potential consequence on a large scale failure is still pretty great. So, that's why we exist. But New York City, to that point, they have to take these worst case scenarios into account for their systems. When you have that many people living in that kind of environment, won't say failure isn't an option, but safety has to be at the absolute forefront of everything you do. And so the requirements there are a lot more stringent. So,
don't they have to put batteries not inside the building, but perhaps on the roof? Is that right?
They don't have to be on the roof. You're correct in that indoor installations in New York City are still a while out. But no, they can be ground level. They can be on rooftops. A lot of them are going on roofs because there isn't a lot of ground level real estate available in the city, especially with kind of the distances you need for safety from adjacent exposures and things like that. But no, they're not absolutely required to be on the rooftop. That's just one of the more convenient places for them right now.
Got it. And let's talk more about AHJs. You mentioned that New York and California are kind of on the bleeding edge of this. And, there's a handful of markets where storage is really taking off. Hawaii, California, Massachusetts, New York, New Jersey to some extent now. And then here in the Midwest, we are doing storage, especially paired with solar because of the ITC. We're doing about 6 megawatts in Illinois this year. And we're using batteries for a myriad of services like frequency regulation, like capacity charge reduction. And when it pencils, it's a beautiful thing. It adds tremendous ROI to solar projects. But AHJs, they're in a tough spot right? They are in charge of making sure that infrastructure is safe for all of humanity. It's a big job. What is your perspective on, how this is rolling out and how good a job are we doing?
Yeah, I would say we're doing a better job. We're doing as an industry, we're doing a drastically better job than we were doing 2 or 3 years ago. And we're playing in a different league, I would say, than we were 4 or 5 years ago when it was, no, don't call the fire department. They may try to stop us. So in general, things are getting better. We're very much a fire service centric company. Cliched though it sounds, we refer to ourselves a lot as a company of firefighters for firefighters. We're up to 12 guys at this point, and that we have some really strong engineering chops. We've got 5 guys, I think, with engineering degrees. Most of our guys are either current or retired firefighters. I myself was a volunteer for a while, before I landed in the battery world. But a lot of our guys are retired chiefs from these big urban centers. New York City, you mentioned, Boston, Arizona. We've got fire guys from all over the place. So that's very much our focus, and getting these things, building those relationships with the fire service and getting these things in. Um, One of our fire guys is apt to say that the fire service they don't get to pick the risks. If it was up to them, everything would be built out of wood, and you could put it out really easy, and then everything would be, well with the world. But the fact of the matter is the built environment is getting increasingly complex. It's getting increasingly riskier with some of the chemicals and the materials that we're using, with the amount of energy that the average human demands on a daily basis. The world, in some ways, it's getting safer. In other ways, it's getting more dangerous. And fire service, they like to joke that they're a 1,000-year-old brotherhood unencumbered by progress. They very much are at the bleeding edge of the technology revolution we're going through as a society, and understanding those risks. So, a lot of times they're viewed as an obstacle to a project. They're viewed as somebody who can shut them down without adding any value. But that's not really the case. In a lot of cases, the fire service, they want to be able to permit these systems. They don't want to be seen as Luddites or obstructionists to the technology, but it does need to be done safely and in a manner that's safe for them to respond to, in a manner that's safe for life and the property and the environment in the area where they're at. So their job is not to be an obstacle, but in a lot of cases, the industry needs to meet them halfway, and not everybody in the industry has done that to date, but in general, the industry is doing better.
And tell us about the services that you provide to authorities having jurisdiction.
Yeah, sure. So, as a company with a strong fire service background, uh, you know, one benefit we bring is that we can walk straight into a meeting with an AHJ or with the fire department and immediately speak their language. I think one thing that helped me, 5 or 6 years ago when I first got into energy storage safety, was that I spoke battery and firefighter, and there weren't really a lot of people in the space at that time that could do that. It was beneficial to me, but it's something that the industry still needs. We've got a lot of fire guys on our team, so it means when we have these conversations, we are immediately are able to establish rapport and a level of comfort with the fire service. But prior to going into those meetings, we sit down with our clients, and we kind of give them a bit of a reality check. We what looks dangerous to an engineer or looks dangerous to a project developer, in the way these batteries burn and in the potential risks that they bring, really isn't that big a deal to the fire service relative to some of the things they deal with on a daily basis. It's just a matter of being honest with them, presenting it in the appropriate context, and explaining to them how they can manage it safely. We try to bring our clients onto the same page as the fire service so that they really understand what they're looking at. In a lot of cases, they don't have a fire background. I'll be honest. One of my first clients that I worked with an AHJ, we showed them what their battery looked like during testing, and by all accounts, it was pretty good. They were terrified, and I asked them if any of them had ever actually seen a house fire. And I was really surprised when all three of them said, no, we've never actually seen a house fire. So I sent them a couple of YouTube videos. I'm like, this is what it looks like. And they're like, oh, yeah, I guess this all makes sense now. So Just educating folks so that everybody's on the same page when they're talking, so that the energy storage industry doesn't feel like they need to hide anything from the fire service, but also so that the fire service understands that, hey, all these crazy videos you're seeing on YouTube, yeah, these things can be bad, but they can be managed. And we're going to be here and we're going to show you how it's done. We're going to help you put together a plan. And, if our clients want us to, we'll be on the other end of the phone if you have an emergency and need a subject matter expert. So, along with that, we're heavily involved with UL and NFPA standards. I'm on 6 UL STPs myself personally. Myself and my co-founders are heavily involved with both NFPA and IFC code development. And in addition to being experts in the codes, we're also experts in how these things go in the ground. And the goal is just to kind of make everybody comfortable.
I want to talk about the Arizona fire that happened, that got in the news, and I think gave some professionals pause about the way we were developing storage projects and about how storage projects are installed. Frankly, there's many pieces to the puzzle.
Yep.
There's the storage itself, there's the containerization of the storage and how that is all engineered and what happens under different scenarios. But and this is very relevant for project developers and owners who, look to that as a worst case scenario where some first responders were injured, and it was a bit of a black eye on the industry.
Mhm.
So, with any new technology, there's going to be accidents, and they're just higher profile because of the newness of the technology. Well, what happened there, and what is the industry doing in response to what happened?
Yeah. So, a few things to throw in there. And, there's 3 reports that are out about what happened. 2 of them came from the opposing sides there, and I won't dive too much into those. UL also put out a great report about looking at the firefighting response to what happened there. But, to be blunt about it, what happened at Arizona was theorized verbatim by myself and dozens of others in the safety community 2 years before it happened. One of the comments, I think, in one of the reports, uh, talking about the incident was that, yeah, we absolutely knew this was a possibility. We didn't think it would happen the way it did, but lo and behold, it did. And everybody who knew anything about these systems and knew about safety predicted it was going to happen, and it played out, exactly as we said it did. So, I think the good news is that rather than us just saying it and coming off, a little bit like Chicken Little, if the sky is falling, we now have something to point to as validating us. And fortunately, nobody was killed, but it is very tragic that some of the guys were hurt as bad as they were, and for the length. And fortunately, everybody's okay now. But it was not a good look for the industry. To be entirely honest, that incident is exactly what we put ESRG together to manage. The fallout from that incident and the cleanup, the investigation, and everything that followed that were things that we identified that were going to be issues for the industry. Unfortunately, we weren't fully together yet as a company and ready to respond to that, but that was exactly what ESRG was put together to respond for. And to be entirely honest, we had another explosion in Liverpool in the UK a few weeks ago. I guess a couple of months ago now. There was actually a ferry explosion in Norway about 13 months ago, where a hybrid ferry exploded. And there's been a lot of residential ESS fires of late. There's been a lot of EV fires. Again, I stand by the statement that you made that batteries are getting safer, but we're building hundreds and thousands of times more than we were, 5 and 10 years ago. And so incidents are going to be a reality. How you respond to them is key. You can build the safest battery in the world, but quite frankly, we just don't know everything about how they're going to fail. The fire service needs to be trained. I think the industry appreciates that now. There's a lot more effort to do that. It still has a little ways to go. We're working with folks to make it better. A lot of other entities are working with folks to make it better. But firefighter training and proper emergency response planning needs to be at the front of your mind in every project you deploy. And it has to be custom for that site. It can't be a rehash from another site with a different department with different resources with a slightly different lay of the land. Safety needs to be done on a site and system basis, and the industry is doing that more. We'd like to see them be even better at it, but that's one takeaway I think from Arizona. I mentioned that we want to be your subject matter expert. If you feel you can't confidently respond to it, we're still seeing a lot of it's a word I want to use here. A lot of insistence from industry that they've got these 24-hour command centers and they've got SMEs who are going to take care of it. I think the next thing that worries me is we're not convinced that's the case for all folks. I hope we're proven wrong on that. But, I think the important thing going forward is that even after you train the fire service, you've got to have knowledgeable people there to guide them, to provide the appropriate information to everybody to make sure everybody stays safe. But response, I think, is really the future of safety. As 9540A gets better and as the fire protection engineering technology gets better, we need to make sure that the human factors and the response continue to improve too.
It seems to me there's two things that can go wrong. The core elements of the battery can catch fire and thermally run away.
Yep.
Lithium is quite prone to this as an element. And then there's the gases that can be produced by batteries, I guess, under normal circumstances and abnormal circumstances. Do you or does the industry differentiate between those two?
Yeah, so just a couple of points of clarification there. Lithium-ion batteries by nature are not the same as the elemental lithium that you may have thrown in a pool or thrown in a bottle of water as a kid that starts fizzing and hissing. It's completely safe to put water on lithium-ion batteries. The ion aspect of lithium-ion means it's stable in that regard versus elemental lithium that tends to love to make hydrogen gas. The other thing is, and this is actually kind of a continuing point of contention in 855, lithium-ion batteries should not be generating gas during normal operation at all. If you have a battery that has, the vent or the seam or whatever it is has failed and started to produce gas, that battery is failing. There is not a normal condition where those batteries produce gas. And there are technologies out there now that are actually designed to detect very low levels of that gas to detect failure before it can potentially occur. The Lion Tamer being the product that's jumping to mind right now. Yeah, there are a lot of things that can go wrong with batteries. There can be internal failures in the battery themselves. That was the cause of a lot of failures in the early days of the technology, as I understand it. In general, I think the industry needs to give themselves a pat on the back because those kind of internal defects are few and far between, even as production has scaled up by orders of magnitude. What we're seeing now are challenges with the complexity of putting tens and hundreds of these systems together. Monitoring is inadequate in some cases. You short circuit a single cell and 3.5 volts and whoop-de-doo, but suddenly you get a ground fault with a 1,000-volt system and the currents and everything else, the energy expelled during that is a lot greater. You get unintended failures, you get human factors in there, you get mechanical issues, a whole slew of different failure modes, HVAC failure being one of the big ones we see, where the systems start to get exposed to a lot higher temperatures than they should be. So a lot of ways these things can fail, and then you're absolutely right. There's a fire risk, there's a buildup of gas and explosion risk. One of our approaches to system design is trade-off between heat and gas and fire and explosion risk. In some cases, you want to avoid fire at all costs, and you do that by taking on a little bit of explosion risk to stop the fire, kind of keep it choked and oxygen depleted and get that gas out of there. In other cases, it's a lot safer to let the battery burn. That's actually kind of the approach for the industry now to fire safety. There are a lot of caveats that come with that. We don't love when people just tell the fire department, let it burn, because it's really missing the forest for a single tree. But it's definitely one thing to consider with safety.
Well, we just have a few minutes left. I want to really address how ESRG works with project developers and project owners. Let's dive into that for a few minutes.
Yeah, sure. So, right now, a lot of what we would our offering would be pretty standard consulting services. We've got some exciting, a couple partnerships now with fire protection engineering groups. A really exciting partnership that we're about to announce now. In a few weeks or maybe a month or so, with a firm to expand capabilities from cradle to grave for energy storage. But the focus right now is to work with folks to evaluate system safety. I mentioned hazard mitigation assessments, just general third-party assessments in cases where there aren't really fire codes. What are we doing right? What are we doing wrong? What do you tell the fire department? We help the system get permitted. We provide the emergency response plan for the fire service. We do training for the fire service. Our training is unique in that we typically prefer to train the subject matter expert for the project developer or for the owner operator of the site. Murphy's Law says that if you go train, 30 firefighters on a 32-man department, that the two guys who respond are the two guys that weren't trained. So we want to make sure that, somebody on site, we've worked with, they understand what's going on. Everybody understands each other's risks. Everybody understands each other's liabilities, each other's responsibilities. In a lot of cases, we tell the SME, your biggest responsibility is to hold the fire department back if they want to go do something that is unsafe. They may not like it, but your obligation, your responsibility is their safety. So it's a little bit of a unique approach to training relative to the way some folks give it. But we feel it's critical to build those relationships and truly to keep people safe. I think one thing that we're starting to offer now that is unique, that doesn't fall into that consulting space, is the 24/7 SME and emergency response service. We're in the process of building out pretty broad software platform for that, and we'll have more to talk about in the coming weeks and months with the software platform that we're developing. It's going to cover all things safety, but potentially a lot of other stuff, and we're really excited about it internally. But what we're doing in the immediate term is we can be that SME on the other end of the phone. We can have access to your data streams, have access to third-party data streams. We can interact with the fire department on the ground, especially if we've already put the ERP together for them, if we understand the system. And we can supplement your technical expertise or your control room guys and make sure when the fire service is responding, they're doing so safely, they're doing so effectively. But then after the incident has ended, or once we've got the site secured, we start the investigation. If one needs to be conducted, we start the insurance and claims process. We start the disposal process. If any hazmat remediation is necessary, we'll start that process as well. But our job is to make your management of the end of the life of this battery as easy and as streamlined as possible. Quite frankly, we've been involved in some failures where that cleanup did not go well. And, as bad as an incident where people get hurt are, hopefully we can minimize those immediately. But if these systems sit around for months and years after a failure or a fire and become an environmental hazard or a hazmat hazard or an eyesore, that's not going to be good for the industry either. We want to make sure in all cases that's taken care of, both for the sake of the industry, but for our client and the environment as well.
Does the safety of a storage project change over time significantly? I'm thinking of, how batteries do degrade over time. And what I see a lot of news about is that we're going to take mobile storage and convert those to stationary storage. And so, yeah, I'm just curious, as if a battery is 2 years old versus 10 years old, is there any greater hazard related to that installation?
I think there are probably three factors at play there. One is the battery itself, and UL is doing some really great work in that regard, looking at the hazards posed by second use and degraded batteries. I haven't seen all the research that's come out from that. Judy at UL is finishing up that work now, and when hopefully when that's done, they'll be able to present that and kind of fill in those gaps, because that is a concern. The second facet of that, I think, is how the systems are integrated. So electric vehicles have the fear of litigation that forces them to build incredibly safe systems because people's lives on a daily basis are at line. are at risk if something goes wrong there. So the control systems in electric vehicles, the construction of EV batteries is very different. It's a different degree of safety than what the stationary industry is really building to, because it has to be. So, the batteries themselves should be adequate from a safety perspective. UL is working on some standards to ensure that that's the case. They've got a little bit of a ways to go before they're ready for prime time, but the ball is rolling. I think the concern is going to be in how they're integrated. If somebody just goes and grabs a bunch of batteries off the shelf out of an electric vehicle, slaps them together with a rudimentary controller, and hits go, I think people are really going to struggle with maintaining those systems in a good functional way. They're not going to work as expected, and they're going to have some safety considerations if appropriate engineering isn't done to the battery and corners are cut. So in general, you're kind of going to have to treat a second use system from an engineering perspective the same way you would an initial use system. But the balance and control of that system, because the batteries are degraded, may be a little more challenging. Maybe easier if you can bend them because you've got more robust control architecture, but it could be more challenging in other ways. So we'll see how that plays out. A lot of my initial experience with batteries was controls. Got a lot of respect for the challenges that can go wrong there and what poor controls can do with respect to battery failure. So we'll see. And then the third is just the safety aspect over time in terms of how the human factors change. Has the fire department turned over a lot of guys? Is there a different owner operator of the system? What is that response going to look like 5 or 6 years after the battery was put in the ground? Has everybody forgotten what they need to do? Has everybody forgotten the risks? Is that emergency response plan still active? Is somebody storing 100 gallons of diesel fuel 5 feet from the container? What has changed in that regard that may impact the safety of the system?
Got it. We're going to give our listeners a way to reach you. But before I do that, I want to make a quick announcement. The Solar Podcast and the Clean Power Hour are brought to you each week by Continental Energy Solutions. If you just go to cesnrg.com/videos, you'll find all of our content here. Please do subscribe. That's that red subscribe button you see here is to the YouTube channel, and then hit that bell for the energy transition so that you get all of our updates. But we're bringing you interviews with experts like Michael Mills Price at PVAL on PV inverter and storage scorecards, like solar safety and rapid shutdown with Joe Covington here of IMO Fire Raptor, and then of course the Clean Power Hour with myself and John Weaver. Please go to cesnrg/videos and check out all of that content. I want to thank my guest today, Nick Warner of Energy Storage Resource Group. Nick, you do have a name change coming up. Give us the lowdown on the name change that's coming and how people can reach you.
Yeah, so we started with a focus on energy storage. We're still predominantly an energy storage company, but our expertise in fire investigation of energy assets, our expertise in permitting of novel energy assets has expanded into other industries, wind, natural gas in particular. And so very soon, Energy Storage Response Group is going to be Energy Safety Response Group. Still the same team, still doing a lot of the same stuff, but with a fancy new brand and fancy a name that kind of conveys our broader mission to improve safety across the whole energy world. So
excellent. How can people reach you, Nick?
Yeah. So info@energyresponsegroup.com is the email. You'll get me directly with that. You can also go to our website, energyresponsegroup.com, and find our contact info there, or through LinkedIn, where we're pretty active and have our contact info. So look forward to hearing from folks with any and all their questions and comments about energy storage safety, about continuing to improve the state of the art of safety in the energy storage industry, and helping the energy storage industry improve safety and public safety relationships, and getting this stuff in the ground in a way that makes everybody not just happy that they're saving the world, but also confident that they're doing it safely.
Well, thank you. I look forward to having your group back on the show in the future. There's so much to talk about with energy storage, and it's such early days. So thanks everybody for listening, and let's grow solar and storage. I'm Tim Montague, your host. Have a great day.